Hello friends, today in this video we will discuss data visualization, various plots using different libraries, when to use which plot and how to understand each and a specific plot with different features. So firstly we have the comparison table of the libraries which we are going to use. For data visualization, basically, we use these three libraries in Python. One is Matplotlib, another one is Seaborn, and the third one is Plotly. Now, what are the different features they possess? So, firstly, we will go through it. So, if we check the level of the graph or the plot, so in Matplotlib, it is low level and it is customizable. We can do customizations. Seaborn, it is high level, easy, and for statistical purpose. Plotly, high level plots we can create, and the best part is they are interactive. Means we can interact with the plot. If we put our cursor over somewhere, it will show us data. We can interact. So these are dynamic. So that is the interactivity part. If we take Matplotlib is mostly static. C1 is totally static and Plotly is fully interactive. Okay, this is the best part of Plotly. Ease of use, Matplotlib medium, C1 is easy, Plotly is again easy. Best for Matplotlib is best for research and publications, Seaborn is for statistical analysis, Plotly is for exploratory data analysis, dashboards and web apps. Integration, if you call about, so we can integrate with NumPy, Pandas. Here we have Pandas, Matplotlib, and Pandas and Dash. Can we create 3D plot? With Matplotlib, yes, we can create. With Seaborn, sorry, we cannot create 3D plot. With Plotly, we can use. Styling, styling of markers and each and everything. Matplotlib, it can be manual. Seaborn, it is automatic. Here it is automatic plus interactive in Plotly. Okay, so you can go through it, take your time, and uh, we can go further. So firstly, what we will do, we will import these libraries. So I have written comments as well so that it will be easier for you to understand. So I'm importing Seaborn and the object will be SNS. So instead of writing Seaborn each and every time, I will directly write SNS, and SNS holds each and every power and properties of Seaborn. So the same way import matplotlib dot pyplot as plt is the object now, and dot plotly express we have px is the object. As we have to deal with data frames, so we need pandas. So we have created object for pandas as pd. Okay. Now, so let me run this. Control plus enter. Okay. Now here I am going to get my data set, my data frame, and here in this case for the visualization I have taken iris data set. Iris is a flower with a sepal length, sepal width, petal width, and three different categories. Okay, so this is how we can import our data set. So whatsoever we will import, it will be stored in iris. Okay, so just to check what are the field names in this data set we have, we can write head or tail. Okay, it will show us first few records if we write head, and if we write tail, it will show us the last few records. So this is how, if I run this, now see, this is the output. What are the fields or variables we have? Sepal length, sepal width, petal length, petal width, and species. Now here these variables sepal length, sepal width, petal width, these are our continuous data. Okay, but here if we see species, it is our categorical data because we have three different types of categories of iris flowers. Okay, so this is our data set. Okay, about our data set. Now, after understanding the variables in the data set, let's create a pie chart. So I'm going to create a pie chart using Matplotlib library. So pie chart for flower species count. Okay, now the first question is when we create pie chart. We create pie chart when data is qualitative or categorical and we have single variable. In that case, we create pie chart. So here for the pie chart, we need to create it for categorical variable. But here in all these fields, we can see only one categorical field, that is species. So that is why I will create pie chart for species, that is categorical. So iris, we know the role of these bracket, species dot value count. What value count will do? Value count will give us the frequency distribution of each and every category in this field species. In this field species, one is Setosa, another one is versicolor, then Virginica. So these are the three species. Okay, so I want the frequency distribution of all these species in the complete data set. So let's check, and whatever the output we will get, it will be returned into species count. It will be saved in species count. So let me run this and let's check what we have in species count. Now see, Setosa 50 data points we have, versicolor again 50 data points, and Virginica. So in total we have 150 data points, and we can see that category wise for Setosa, versicolor and Virginica data is normally distributed. Okay, means 50 50 50, we can easily figure it out. Okay, so let's create the pie chart. For that I have taken PLT. Now see, PLT is the object of Matplotlib. Okay, so PLT dot figure, here we will write the figure size. Figure size means in inches how much big or small our figure will be, the output, the plot will be. Okay, so I have chosen 4 by 4. You can customize it according to your interest. Then plt.py, because we are going to create pie chart. For pie chart, we will give a species count, because in this species count we have the number of records for each category, 50 50 50. So we have provided here. So exactly same. Labels is equals to, labels will be equals to species count dot index. Now what index will do here? Index will return the label names. Label names means Setosa, versicolor and Virginica. I want in my pie chart that these labels should also, it should be depicted, it should be revealed, so that I can easily find out which portion of the pie is belongs to which category. Auto percentage. Here, sorry, here percentage 1.1, it is used for one decimal point. Okay, and this these two percentage symbols, they will give or show one percentage symbol. Okay, it will display one percentage symbol. Start angle is 90, means pie chart will start from 90-degree angle. Okay, this is just if you want it, otherwise you can remove it, but I'll show you what difference it will make. Okay, next I want what would be the title of my pie chart. So title will be the distribution of iris flower species. It will be my title. And finally, I will write this command plot.show, plt.show. PLT is object of Matplotlib library. So now if I run this complete code, if I run this, control plus enter. Now see, this is the distribution of iris species. Figure size is 4 by 4. Let me make it 3 by 3 so that and run this. So now this is the okay. Can we see 33.3? One decimal point we are having because it is due to percentage 1.1f. Then after that we have this percentage symbol. It is because due to double percentage here. Start angle is 90. See, this is 90 degree. From here it is starting. Okay, if I remove this start angle, just a minute, Control F, and now we'll see that this will randomly it will start from anywhere. Now see, it is not starting from 90 degree here. Okay, so randomly it is starting from. So if you want, you can use it. So here we have labels as well. Blue color is for Setosa, green is Virginica, and versicolor is 33. As we have already, as we know that the data is equally distributed for each of the category. Setosa, versicolor, and Virginica all are 50%. That is why we have 33.3% for each of the category. So this is how we can create a pie chart using a categorical variable for plotting. Now, let's come to the bar graph. When we create bar graph, see, here we have used plt.figure, again figure size. Now SNS Seaborn I'm using for bar plot. Data I have to reveal, I have to tell which data set or data frame I'm going to use. So data will be my iris data set. X axis will be the species and Y will be my petal length. Okay. And palette is cool warm. Palette means palette is a combination of colors. So by default there are many different palettes provided by Python. So I have taken cool warm here. Okay, so the color combination. Finally, the title of the plot, it will be average petal length per species. Okay, when there is some order, data is categorical and there is some order, ordinal data, in that case we use bar plot. So let's create, let me run this. Now see, this is the plot. Setosa, versicolor, virginica, these are the species. On y-axis, petal length. So we can see that Setosa is having the minimum petal length. Versicolor is having little bit higher petal length, and Virginica is having the highest petal length out of these three categories. So we can easily find out that the size of the Virginica flower, it will be Virginica category or species is bigger than other two. Okay, now use box plot. We use box plot in two cases. When we have a single variable which is uh, quantitative in nature, or another case is when we have two variables, one is quantitative and one is qualitative, then we create box plot. So let's create box plot. Let me check the iris head as well again, just to see what are my variables, and sepal length, sepal width, petal length, petal width. Okay. Now for box plot again, figure size we have to define. Figure size is like common in all the graph. Okay. So plot dot figure size is 4 and 2. SNS dot box plot, data we have to provide. Data is our iris data set. X axis, it will take our species, means categorical. In y-axis, we have taken sepal width, which is continuous. So here we can easily find out one variable is categorical, another one is continuous, or means we have both the variables, quantitative and qualitative. In that case, we can create whisker box plot. Palette again, which color combination you want. So set 2 as well we can use, or you want if you want your customized, or according to your interest you want colors, so you can write in this way as well. Palette is equals to red, green, blue. Okay, so according to the species, these colors will be allotted. Red to the first one, Setosa, then versicolor, then virginica. So respectively, these colors will be allotted. Okay, again, plot dot title, box plot of steeple width by species. Then finally, plot dot show. So if I run this, now see, this is our whisker box plot. As we all know, whisker box plot. This one is the minimum value, minimum data point. This one is the maximum data point, highest data point. In this box, the lower line is our first quartile, upper line is our third quartile, and the line in between the box, in amid the box, this is our median. Okay, here we can see that species is here. Species Setosa versicolor virginica, this is categorical variable, and here sepal width is, this is quantitative variable. Here it is continuous. So see, when we have quantitative as well as qualitative variable, so in that case whisker box plot is the best option we have. We can use histogram as well in that case, but still I prefer whisker box plot. As a whisker box plot, it shows or depict the outliers in the dataset as well. So if we can see in Setosa there are two outliers at the minimum side as well, at the highest side as well. So these points, these markers are our outliers which are not included. Means out of 50 Setosa records or observation, out of 50 there are two data points, this one and this one, these are not included. These are the outliers. And in virginica also we have outliers, but in versicolor there is no outlier. So all the data points are included. This one is the minimum value, this one is the maximum value. Okay, now histogram using Matplotlib and Seaborn. Again, figure size you have to define. After that, sns.histplot. This is the function we will use to create histogram. Data, which data set we are going to use, that is iris. On x-axis there will be petal length. Bins is equal to number of 40. The towers which we see, the rectangular boxes in histogram, they are known as bins. So number of bins you want. So I have written 40 here. If you want more or less, it depends on your interest and requirement. Okay, if you increase the number of bins, it will be more detailed. If you decrease the number of bins, it will be summarized, more summarized histogram. KDE is our kernel density estimate. It will show us the frequency distribution through a line. I'll show you. Okay, then color will be the dark blue. The color of bins will be dark blue. It will be filled with dark blue color. And again, for each bin there will be boundary of each bin or bar. So I want just to make it clear or separate the bins. I have used H color, and which will be of yellow color, so that I can easily find out the boundary of each bin. And finally, the title of the plot is histogram of petal length. Then finally, plt.show. So if I run this, yes, now see, x-axis is our petal length, y-axis is our count. Okay, here bins are 40. If you see 1, 2, 3, 4, 5, 6, 7, this way you will be having 40 bins. These towers are called bins. Okay, color is dark blue. So these towers are filled with dark blue color. Okay, and if you notice, see, the boundary of each bin is with the yellow color. So as we have already mentioned, that edge color should be yellow. So that is why it is coming like this. Now can you see this line? This line is our kernel density estimate, which we have used. KDE is equals to true. If you do not write KDE is equal to true, or if you write KDE is equal to false, this line will not appear. Okay, but if you want this line in histogram, uh, generally we want this line. So that is why I have introduced this, and this is how we can create histogram. Now, a scatter plot. When we use a scatter plot, when we have two variables and both are quantitative, in that case we use scatter plot. It tells us the pattern, how each data point is behaving with other data points. It means how x-axis and y-axis are behaving, what is the correlation, we can easily find out by just looking on the graph. So figure size is common in all the graphs. Then SNS dot scatter plot. I want data is again iris data frame. X will be sepal length, Y will be petal length. So now you can see both the variables on x-axis and y-axis, they both are quantitative variables. There is no qualitative or categorical variable, because in scatter plot we want both these variables. Both the variables will be quantitative. Now one more thing, on x-axis, keep this thing in mind that in data visualization, x-axis, the variable in x-axis is our independent variable, and the variable on y-axis is always our dependent variable. So as we have discussed earlier as well, that when we create a model, we use tilde sign. Okay, this is the tilde sign above your tab button. Okay, so before tilde, the variables are dependent, and towards right, the variables are independent. Okay, so hue is for colors, means I want for different species plot will be created for sepal length and petal length, but the data points, we have total 150 data points divided into three categories: setosa, versicolor and virginica. So according to each data point of different category, I want different colors, so that I can easily find out which data point belongs to which category. And then style. Style means marker. You want dot, you want plus sign, whatever. So I want style according to the, again, species. So different species will be having different style and different color as well. Okay. Now S is for the size of the markers for each data point. By default it is 40, but I have taken 80. Okay, so according to your interest, you can customize it. Now finally, plot dot title will be sepal length versus petal length, and plt dot show. So now if I run this, let's see the scatter plot. Now see. So the blue circles are setosa. Can we see that color is blue for setosa and style is circle. For versicolor, color is orange and style is C cross. Okay, so all these data point, cross data point, these are versicolor data points. And virginica, green color with square marker, these are the markers. These are the markers. So all these points, virginica. So virginica is the biggest flower in all these category. So we can see that sepal length, sepal width for all different categories as well. And one more thing we can find out easily, that can we see the trend line? If we create a trend line over here, so it is there is a correlation. Means when petal length increases, sepal length when sepal length increases, petal length is also increasing. So according to this distribution of markers here in this plot, we can easily find out. Okay, by default this plot is showing me legends as well. This is called legends for that, for which species, which color and marker it has taken. Okay, so as this is SNS, means Seaborn, so this is not interactive. If you put your cursor on any of the data point, it will not show you anything. It will not nothing will pop up, or you will find any value over here. So you cannot interact. This is totally static. But using Plotly we will make it interactive plot. Okay, so this is how we can create scatter plot. Now let's come to the pair plot using Seaborn again. Now pair plot will take each and every variable and it will show you the plot for each and every combination of each and every variable with a different variable. So how to create pair plot? SNS.pair plot. Data is our iris. Hue again species. Diagonal I want KDE. Diagonally the plot which will come, it will show the kernel density estimation. Okay, so let's run this first and we will able to understand what pair pair plot is all about. So run. What happened? Oh yes. Now see, we have sepal length, sepal width, petal length, petal width. In the same way, we have sepal length in x-axis, sepal width, petal length, petal width. So it has created plot for each and every combination. And diagonally, if you see, we are having this kernel density estimation for frequency distribution. See, for sepal length, this is the curve. For sepal width, this is the curve. See, diagonally, we are having KDE and uh, rest we have sepal length with sepal width. This is the scatter plot. Sepal length with petal length. This is the plot. Sepal length with petal width. This is the plot. See at the bottom, petal width. Can we see? So here we can see the combination, the pairs, okay, of each and every variable. So sometimes it is very good to see these sort of plots. Okay, now let's create the interactive plot, the dynamic plot through which we can interact also. Okay, so we can use Plotly for the purpose. Now here figure is equals to what I'm doing px dot scatter. Px I have taken for Plotly. I want a scatter plot. Iris is my data set. X-axis will be my sepal length, y-axis will be my petal length because I am creating a scatter plot. Again, a scatter plot when we have both the data, both the variables are quantitative. So x is sepal length, y is petal length. Color will be equals to species. According to the species, there will be color. Size will be equals to petal width. See the markers here, as we can see, these are the markers: orange marker, blue marker. These are the markers. So if any flower or any data point is having petal width is higher, the size of that data marker will increase. Okay, so now we can find out that how in layers we are using at different layers for plotting purpose. If size of petal width is higher, then marker size will also be higher. It will be greater. If petal width is smaller, then the marker size will also be smaller. I will show you. Hover data. What is hover data? When we put cursor on any of the data point, let us suppose I put my cursor on this data point. So a small window will pop up here that is called hover and it will show me the details of this data point, like what is the y-axis, what is the x-axis, what is the category, which species this data point belongs to. So all these things it will show me in that hover, in that small box which will pop up. So hover data, it will be according to the again sepal width. Now so this is the variable figure. Whatever we have done here, it will be stored in fig figure. So figure dot update layout. Now see how many, what are the things which we can, means how we can play with the data. Title, it will be text and it will be title will be interactive scatter plot using Plotly. X is equals to 0.5 means the alignment of the title. If I put it 0, x is equal to 0, it will be on the left hand side. 0.5, the title will come on the center of the graph. If I make it 1, it will go to the right hand side of the graph. So now according to again your requirement, you can make it. Title font. The title, the font will be I have created dictionary. This is my data structure which we have already discussed. You can go through the starting videos of Python. You will find out the what a dictionary is all about. This is a data structure. Size is equals to 20. Family, which family? Font family. See, we are working it for title font. The font family will be Arial. You can use Times New Roman, Calibri, anything. And the color of the title will be dark blue. Now, after that, I want background color of my plot. It should be burley wood. Okay, something nearby, near to brown color, burley wood. Okay, so background color you can also define. If you do not write it, the plot will again, it will work, the coding will work. But what are the features, what are the different features you want to include in your plot to make it more beautiful, make it more descriptive, to make it more alluring, eye catching? So you can use these different features. There are n number of features. Okay, so for x-axis, show grid. Yes, if you remember, we used graph books or graph copies, graph papers. And there we have units for 1 centimeter, 2 centimeter. There are grids. So, do you want to show the grid lines? Yes. So, if you want, please make it true. And for x-axis, axis, grid color will be light gray. This is what I have taken. You can customize it. For y-axis, again I want to show grid lines. Okay, and grid color will be pale green, closer to light green. Okay, x-axis underscore title. So sepal length, it will show on my x-axis. Okay, label, and y-axis title will be petal length. Width in pixel I have given 900 and height will be 500. Now if I run this, let's check. Wow, this is the plot. Interactive scatter plot. See, as I told you that if if petal width will be higher, size of the markers will increase. Now see, this blue color is for Virginica. Virginica is the biggest category in iris flower. So here you will see that if I put cursor on it, it is showing me data. Species is Virginica, sepal length is 7.9, petal length. It is showing me each and every details of each and every data point. 150 data points we have. And see, this Setosa is the smallest category of iris flower. So the sepal width will be lower. So that is why the data point, the markers are, this is very small. This is little bit bigger marker. And for Virginica, big circles are here. For versicolor, it is little bit lower down. For each and a specific data point, it is see, this is how much descriptive this plot is. And again, because this is very small data point, so sepal width will be very less. Sepal width is 3, and here you will see sepal width is 2.5, something like this. So, and interactive. See this color, background color. This is Burleywood color, which I have plot dot background Burleywood. Now see these lines. Can you see these lines? The vertical lines for x-axis. Okay. Show grid, yes, true, and light gray color for x-axis. For y-axis we have pale green. See, for y-axis we have grid lines are green color, pale green color. Okay, so this is how we can create interactive scatter plot. Now see, this is the title. For title, I took this blue color. Okay, title font color is dark blue, and if you remember, I told you x is equal to 0.5. If I make it 1, now what will happen? This title will go shift towards here. Okay, so if I run this, now see the title on the right hand side, but if I want this title on the amid at the center, so again I will write 0.5 and let me run this. Again it is here. So this is how we can create interactive scatter plot using Plotly. Now the violin plot, very important plot. Uh, uh, plt.figure, figure size, the same code we have using Seaborn. Violin plot, this is the function to create violin plot. Data is iris, x is equal to species, y is equals to petal width. Palette, again the color combination will be cool warm according to the species. Okay, and title will be volume plot of petal width by species. Now here I have written one comment. Violin plot combines box plot plus density distribution as well. So it is on the higher side than whisker box plot. It will show you density distribution as well. Okay, so if I run this, now see, this is the plot. Okay, so let's understand the violin shape. The width of the violin at any point shows data density. As in Setosa, here's the width. Width is very high. Means density at around 0.25. See, Setosa is having the maximum frequency petal width. So maximum data points are here only. Okay, this is the wider part. More data points at that value, at this value. More data points are here. If there is some narrow part, means there are few data points. Okay, inside this, see, so this is this while in the outer area it is showing me the frequency distribution, where if here the violin is very wider, in that case there are maximum data points of Setosa category, they lies here at this point. Okay, inside this we can see whisker box plot as well. So in this whisker box plot, the minimum value, the maximum value, and you can see one dot, small dot over here. This is the median. So here we cannot show the line for median. So that is why it is showing me through dot that this is the median. Okay. So here in violin plot also, if we see the x-axis, this is my categorical variable, and here on y-axis it is my, these are my numerical values. Okay. Now one more thing, if we find tail, let's see in this violin for Virginica, I can find tail over here on the lower side. It means data is left skewed. Skewness, if we talk about, if we find tail on the bottom side, it is left skewed. If we find tail on the top higher value side, then it will be our right skewed data. So this is right skewed, this is left skewed data. So again, this is whisker in between, this dot is our median. See here, if we see multiple peaks, like this is one peak, if we see another peak as well, okay, so it means it shows multiple clusters will be there. What it means, this means that the data has more than one common value range. Means if data is um, if the range is data range is maximum here, and if we have one more peak somewhere over here, so again it means data has more than two. We call it multi-model data. We call it multi-model data. Okay, so this is my violin plot. Violin plot also show outliers as well if there is some outlier. Okay, but above here we have taken petal width, so might be in petal width it is not showing any outlier. Okay, so finally we'll come to the heat map. Heat map, we use heat map for to check the correlation between the variables. Okay, so using the Seaborn we will use it. Again, this is the same line. SNS.heatmap. Iris is the dataset .corr. We want correlation. Correlation of numeric only values. Here we have categorical variable also in Iris dataset. As now see, species is also there, categorical. So I do not want to include this variable species here for correlation. I want only these for numeric values variable. Okay. Annotate, here we use annote for annotate. It will show me, if I make it true, it will show me the value of correlation inside the heat map. C map is color map. Color map is I've taken plasma. Other is verdes, plasma, greens. So there are multiple combinations we have. So we can choose any of the one. Line width, line width of squares. It will be 0.5. The distance between two squares. Okay, and finally plot.title and plot.show. So if I run this, now see, this is the heat map. Petal width, petal width with sepal length. Oh, see, this is value is 0.82, highly correlated. Okay, so if color is light color, see yellow, light color, so it is much closer to 1, so highly correlated. And if color is on the dark side, then it is negatively correlated. So see all the colors, dark color, here it is 0.12 negative, so it is purple, but if it is higher on the higher negative side, the color is getting more dark, blue color. So for sepal length and sepal length, the correlation will be 1 always. So diagonally we will find these values as 1, 1, 1, 1, 1. Okay, so this is one uh, color mapping we have done. If I let us use word here. Now let's check what will be the color of the heat map. Now see, this is the color of the heat map. So greens, the combination of green colors. Now see, so there are by default Python has provided us many color combinations. So whatever suits you, you can opt it. So this is all about data visualization, creating different plots according to the variable type, which type of variable we are having. Either we want interactive plot, we do not want dynamic plot, static plot we want, and pair plots. So there are many things, scatter plot. So this is how we can create our plots for different type of variables. So thanks for watching the video.